first thing I want to talk about is the only way we know how to do this so far is to do what with these systems of equations? What did we do with all the systems of equations so far? Very good. So we can do what with them, Gabriel?
Change them into y equals mx.
We would change them into y equals mx plus b. For what reason? Why did we do that? So we can graph them, okay? So let's do that here, okay? Let's take 2y plus 6x equals 3, and let's change it into slope-intercept form. Y equals mx plus b. Gabriel, what'd you do?
I didn't get the first one.
You didn't get the first one? Okay. Can you try it? What would you do?
So, let me write it down. So I subtracted 6x on both sides.
Perfect.
And then I got 2y equals negative 6x plus 3.
Uh-huh.
And then divide both sides by 2.
Uh-huh.
Which gives you y equals negative 3x plus 3 over 2. But I don't
Good.
know if that's right.
It is right.
Oh.
That is right. What's up, Natalie? You wanted to say something?
Yeah.
What did you want to say?
I want to see like the answer in y is 0.
Okay, hold on. So this, do you guys agree, is slope-intercept form of the first equation? Are we all in agreement there? Are there any questions on how I got here? No? Okay. What about the second one? Is that capable, or is that able to be turned into slope-intercept form? McCarvin, what would you say? Yeah? Why? What could we do?
Like, say what I did.
Yeah, what'd you do?
So I subtracted 3x from both sides.
Okay.
And that gave me y equals negative 3x plus 2.
Very good. Okay, now, you didn't have to graph this to know that there's no solution. What about these two equations tells me that they're never going to intersect? Natalie.
They have the same slope, so they're parallel.
Bingo. Highlight the slopes. Both of the slopes is what, Juliana?
3x,
Negative 3x. So if the slope of this is negative 3 and the slope of this is negative 3, we know, based on what Ms. Gagne just told us, that they're parallel, and parallel lines never intersect. So how many solutions does this system have? 0. Because the lines are parallel and will never intersect. Yeah, Alec.
I just thought it was because they're all multiplying something, so I just thought they would never reach the same result they were looking for.
Oh, you didn't change them?
Yeah, I just thought about the solutions being multiplied like by multiple different numbers, and that means they would never get to the same spot.
But you have to account for like decimals and fractions. Okay, you have to account for decimals and fractions, right? For whole numbers, I agree with you, okay? But that what you're saying does not work for like decimals and fractions, right? Because like half of a number could also be there, okay? But that's a good observation. Alec was saying he just looked at both of these and he's like, I don't notice any y or any x value that would satisfy this one equation and also satisfy the second one. He's correct for this example, okay? But that does not work every time, okay? But I like that observation. Any other questions on the warm-up? What would be the only example of getting infinitely many solutions?
Horizontal.
Not horizontal. Natalie?
They're the same line.
If it's the same line. Because if you have two lines stacked on top of each other, how many times do they intersect? Everywhere, right? They intersect at all of their points. So any point on one of the lines is a point on the other line. So all of those points are the solutions. So you would have infinitely many solutions. Okay? All right. Before we go into today's lesson, I want you guys to go to Canvas. We're going to talk about midterms for a second. Okay. So in 5.2, we're doing the exact same thing. We're solving systems of equations, but we're using a new method. We are going to have a total of 3 different methods by the time we're done with this chapter, okay? What was the first method we've learned? How did we solve systems of equations so far? You would plug it in with the point, right? But what would you need to do before you find the point? Graph it, okay? You would need to have the slope and the y-intercept, right? Now we are not going to graph it. We're not going to use a graph at all. We're going to use a method called substitution, okay? Now, I would say about 50% of you are going to be like, I prefer substitution to graphing by the end of this, okay? The reason it's more convenient is you don't have to graph it at all. Sometimes you don't even have to change your equations at all, okay? So step number 1 is you solve for one of the equations for one of the variables, okay? In other words, we isolate one of our variables. Write that down. Now, it does not matter which variable you isolate. It could be x, it could be y, okay? But you have to isolate one of them. What does it mean by isolate? What do I mean by when I say that? Isolate or solve. What does that mean? Andrea?
But it has to be alone on one side.
Very good. It should be by itself on one side of the equation, okay? Then, once you've isolated a variable, you use something called substitute. You substitute the expression from step 1 into the other equation. So now you're using both equations. You're substituting whatever the first equation was into the second equation so you can solve for the other variable. So in systems of equations, right, we have 2 variables, right? We have x and y. Do you guys agree? Once you use substitution, you eliminate one of your variables and you only have one variable left. So your entire equation is going to be in terms of x. Then you can solve that equation, okay? And then step number 3, you substitute the value from step 2 into one of the original equations and you solve for the other variable, okay? Now, the 2 things that you want to look for is you want to know, are either of the equations already solved for x or y? Because if they are, the problem just got a whole lot easier, okay? And then if that hasn't happened already, then the second thing you look for are, do either equations have a coefficient of 1 or negative 1? In other words, are any of them 1x, 1y, negative x, or negative y, okay? All right, let's see an example. So scroll down to A and notice the instructions. It says that we have to solve this system of equations, and we have to use what method? Substitution. So if you graph this, you would get no points, okay? I need to make sure that you know how to do both methods, okay? So let's look at A. It says y equals negative 2x minus 9 and 6x minus 5y equals negative 19. Do you guys agree it's a system of equations?
Yes.
Okay. Is there a variable that has already been solved for in one of the 2 equations? Natalie?
Y.
Very good. In which equation?
The first one.
The first one. So we're going to circle y, and we're going to underline what y is equal to. So you guys agree y is equal to negative 2x minus 9, correct? Now, think about the word substitution. We've been watching a lot of the World Cup recently, right? When you substitute, right, a player approaches the substitute box and subs in for someone else, right? So they get replaced. Do you guys agree? On the field. So what we're doing now is we're going to replace y with something in terms of x. So now look at your second equation. It's 6x minus 5y equals negative 19. Replace y, so there's no longer going to be y in your equation. You're going to replace y with negative 2x minus 9. So watch how it looks. We write the same exact equation, 6x minus 5, but instead of y, I'm putting negative 2x minus 9. And then equals negative 19. Now, look at that for a second, because this is the most important part. Do you guys see the substitution that's happening for y's? Do you guys see it? Tell me now if you don't. Speak up.
I don't see it.
You don't see it? Okay, so AJ, you agree that in the first one we said y equals negative 2x minus 9. So if y is equal to that, I can take this negative 2x minus 9 and substitute it for y. right? As if like y got really tired in a soccer game and we have to replace him with something with x, right? And so we replaced it here. That's why I wrote it in a different color. So now y is gone. Yes?
So we don't want y.
You don't want y. Very good. Y got really tired and you have to substitute him out. Okay? Does that make sense? Okay. Now this is an equation we can solve because we have one variable, which is x. How do I solve this? Mia, go for it.
Can you distribute by -5?
Excellent.
Give it to x and -9.
Uh-huh.
So it would be 6x plus 10x
Mm-hmm.
plus 45
Excellent.
equals -19.
Uh-huh.
And then, do you want me to continue?
Yeah, I would love for you to continue.
And then you add 6x plus 10 is 16x.
Why?
Because they're like terms.
Very good.
And then you add 45. And then that equals -19.
Mm-hmm.
And then you subtract 45.
Very good.
Subtract 45 from each side. Then it would be 16x equals negative.
Take your time.
64.
Very good.
And then you divide.
Yeah, you divide.
And then you divide 16 inside, and then it would be x equals
Who's good with that large division? Andrea?
-4.
Excellent. -4. Guys, give it up for Mia. That was awesome. Okay? So, we got x equals -4. Hey, when two lines intersect, we just talked about this, they intersect at what? What do we get when those two lines intersect? A point, right? And a point has an x value and a y value. We know the x value. What do you think we have to do to find the y value? Natalie?
You plug the x in that we just got.
Very good. You plug the x in. Now, the cool part is you can plug the x in into either of your first two equations. So circle the originals, the OGs, okay? And pick one of them and plug in -4 for x into either one, okay? I'm going to pick the first one because it just looks neater, okay? So it's y equals -2 times, now I'm plugging in -4 where x was. So -2 times -4 minus 9. Karen, walk me through solving for y. Go. Wait, hold on. Yes.
Where did you get the -4?
You just solved for it.
Oh!
So we had to take what you got, which was -4, and we're plugging it in.
To either one of them?
Either one, yep.
Okay.
Mm-hmm. Karen, go for it.
So you multiply the -2 and -4.
Yep.
It gives you 8
Mm-hmm.
minus 9. Y equals 8 minus 9. And then it'd be y equals -1.
Very good. Now, guys, you know how picky I can be. This is not the answer. Remember, where two lines intersect, you guys agreed it was what? A point. How do I write these two answers as a point? Andrea? There we go. This is my answer now, okay? This is my answer. And yes, is that serious, okay? Now, do I just accept this answer for what it is?
Yes.
No. What do I still need to do? Go back and check it, people, okay? Take these two values and plug them into the OGs, the originals, okay? And make sure that they work. Let's do it together. So let's plug it into the first one. Let's label this our check. Our check is going to be -1 equals -2 times -4 minus 9. -1 equals 8 minus 9. That is correct. Plug it into the second one. It's going to be 6 times -4, which is -24, minus 5 times -1, which will give me a +5, equals -19. -19 equals -19. Yes, you have to go back and check it. I know it's annoying and it's tedious, but guess what? It's going to save you a lot of points on a test or a quiz if you go back and check and make sure that your answer is correct. Will I dock you points if you don't check? Probably not, but it's a very good habit to get into, okay? Now, if you don't check on a graphing one, absolutely I'm docking you points because those were approximating, okay? McCarvin, go ahead. Are there any questions right off the bat for that first example? Who already feels like they're kind of falling in love with substitution, more so than graphing? Yeah, I figured it was going to be a few of you, okay? Let's look at the second one, okay? In B, y equals 3x plus 14 and y equals negative 4x. Who remembers what's the first thing we look for? Natalie?
One of them is already alone.
Very good. Are any of my variables already alone, isolated?
Yes.
What?
Why?
Why? Actually, in both of them. Do you guys agree? So I can make either one that I want my substitution. Austin, which one would you pick to substitute? Which of those two would you pick to substitute?
So confused right now.
Just pick one or two. Okay, let's pick the first one. So this y, we're going to substitute 3x plus 14 wherever we see y in the second equation. So it's going to be 3x plus 14 equals negative 4x.
So you should have picked the second one, but it would have been the same thing.
It's going to be the same thing, okay? It does not matter which way you go for this one because they were both isolated for y, okay? Questions so far on the substitution? Yes.
I don't get how you like substitute.
Okay, so you agree that y is the same as 3x plus 14 in this first one? So I'm taking this part, this expression, and I'm replacing this y with this expression. So it's going to be 3x plus 14, where the y was before, equal to negative 4x. Do you see it now? You sure? Okay. Guys, what do I do? Garnice? Yeah. Ah. What's technically, I love that question. What's technically in front of this y that we don't see? A 1. When you distribute a 1, does anything change? No, so we just write it as 3x plus 14 equals negative 4x. Very good question, Garnice. Any other questions on this one, how I got to this point? Who feels very confident in solving this for x? Go ahead, Sophia.
You subtract 3x,
Okay.
and then you get 14 equals x.
Negative x?
No, negative 7.
Oh, negative 7x. Okay.
And then you divide by negative 7,
Uh-huh.
and then you get x equals negative 2.
X equals negative 2. Okay, very good. I personally would have moved the x's to the left because I'm just that kind of person. Okay, I like to have my variables on the left. So I would have added 4x and subtracted the 14 over, but this is also an okay way to do it. Are there any questions on getting x equals negative 2? Give it up for Sophia. Alec, what's up?
I think I solved the y.
You got y?
Yeah.
Can you walk us through what you did?
So what I did was I took the second equation, negative 4x, then I changed the x in the first equation into I think I did it wrong, but I know what I did, but oh no, it's not 8. But you have to I think you have to replace the x in the first equation
Okay.
with negative 4.
Very good. Replace the first equation, the x with negative 4. Mia, does it matter which equation we pick? No. Kira, when I replace x with negative 4, I get 3 times negative 4 plus 4.
It's negative 2.
Whoops. Negative 2.
Yeah.
Negative 2 plus 14. Kira, what do I do next? Okay. Okay, what do I get? So y equals negative 6. That's it? Okay, and what do I get there? Very good. Positive 8.
Oh, no, you're go, I guess.
You figured it out, Alec?
Yeah, I just randomly focused to negative 4 instead of the other x.
Brayden, what's my answer? Emma, help him out. Yep. Good. Negative 2, comma 8. Because where do two lines intersect?
-2,8.
At a point, right? You need to write it as a point. Juliana, to make sure I'm right, what can I do? Plug it in, okay? So I'm going to take both of these values, plug them in for both equations. That'll be my check. Oops. Check. And it's going to be 8 equals -6 plus 14. That one works for the first one. And it'll be 8 equals -4 times -2. 8 equals 8 for the second one. That one works.
Do you have to check them in for both? Or just one?
I would always check them for both, okay? Because remember, it's not the solution unless it works for both equations, okay? Gabriel, how we feeling?
Good.
You sure?
Yeah.
Gabriel too, how we feeling? Yeah? Okay. Any questions so far? Okay, we're going to do D together, and then you guys are going to do C on your own, okay? So look at D. Yep. Why is D a little bit different? Andrea? Very good. X is what's being isolated except instead of Y. So we're going to take this 6y minus 7 and use that to replace X in the second equation. Who wants to take a shot at the second equation with the substitution already in it? AJ.
So it would be 4 and then 6y minus 7
Mm-hmm.
plus y equals -3.
Very good. Guys, I want to be very clear if we see that substitution happening. Do we all see that substitution happening? Give me like a nod or a thumbs up. Yeah? Okay, awesome. Who wants to take a shot at solving this the whole way through? Go ahead, Natalie.
Okay, so first you multiply 4 with 6y and then equals 24y.
Good.
Then you multiply 4 with -7, which equals -28.
Good. I love how you didn't forget the negative. Keep going.
Then you just add on the y outside the parentheses.
Why don't you distribute to the y?
Because it's not inside of the parentheses.
Very good.
And it equals -3.
Perfect.
Then you add the y and the 24y, which equals 25y.
Why do I add those together?
The same, I forgot what the word is called. The same letter.
The same variable?
Yeah.
So we just call them what? Starts with an L. Like terms. Very good, Gabriel. Okay, keep going.
Minus 28 equals -3.
Love it.
I'm gonna add 28
Mm-hmm.
to -3, and that equals 25. Positive 25.
Very good.
So y equals 1.
Because you divide by 25. Divide by 25. Y equals 1.
Good job.
Give it up for Miss Gagne. Give it up for Miss Gagne. There we go. Nice work. Okay. Everything she said was perfect. Okay. Loved it. Any questions on this for Natalie? On how she solved this? We're Gucci?
This is like back to
Okay.
chapter 1.
Kyra, what do we do?
So now you plug it in.
To which one?
The first one?
Okay. Does it matter which one?
No.
Good. So x equals what?
X equals 6 times 1
Good.
minus 7.
Beautiful.
So 6 times 1 is 6.
Mm-hmm.
7 equals -1.
Good. Alfred, what's my answer?
-1, -1.
Very good. And what should I do at the end, Alfred?
Check it.
Good. So plug these back in, and you should be able to check it. Let's check it together. It's going to be negative 1 equals 6 times 1 minus 7. That one works. It's going to be 6 minus 7, which is negative 1. The second one's going to be 4 times negative 1 plus 1 equals negative 3. Negative 4 plus 1 equals negative 3. Negative 3 equals negative 3. That one works as well. Mia, what's up?
When you get the y, like the 1 and the y,
Yeah.
how do you know which one to plug into?
That's the beauty of it. Doesn't matter which one you plug it into. Okay?
I have to plug it into x or y.
You could plug it, no. You have to plug it in for y, but you could plug it into the first equation or the second equation, right? Because let's walk through it. If we plugged in y here, we would get 4x plus 1 equals negative 3, right? Subtract 1 from both sides, you get negative 4 equals 4x. Divide by 4x equals negative 1. What we got for the other one? Yeah. Any questions on these 3 examples? Do you guys feel confident to try one on your own?
Yes.
Okay, go for it. Try C. Well, how do I do this one? We're going to help you. Okay? So, let's take a look at it. What'd you do first, McCarvin?
I figured out the second problem, the y equals, I circled y and underlined the equation
Perfect. Why?
because that's the variable that
Very good. It's already solved for. Keep going.
So then I plugged in the solved equation for y into the first problem for 2y, and I got 3x plus 2 parentheses 1/2 x minus 1 parentheses equals 0.
Perfect. Okay. Then what?
I distributed the 2,
Okay.
and I got 3x plus 1x minus 2 equals 0.
Why?
Because after that's what I got after I distributed
2
2.
times 1/2. Why is that 1?
Because that's when you times a number by 1/2, you're getting half of that number.
Okay, so half of 2 is 1.
Yes.
Beautiful. Okay, keep going.
Then I added 3x and 1x because they're like terms.
Uh-huh.
So I got 4x minus 2 equals 0. Then I added 2 to both sides, and I got 4x equals 2. And I divided both sides by 4, and I got x equals 1/2.
Beautiful. Guys, give it up for McCarvin. All right. Did anyone figure out what y was after x equals 1/2? Did anyone figure out what y was after x equals 1/2? AJ, go for it.
It was negative 3 first.
But why? What'd you do?
I plugged in the x
To which one?
for the second one.
Okay, so y equals 1/2 times 1/2 minus 1. Yes? Okay. What'd you do?
I multiplied 1/2 times 1/2. I
What?
got 1/4.
Good.
And minus 1 would be basically 4/4.
Ah, excellent. That 1 is the same as 4/4. Okay?
It'd be negative 3/4.
So y is equal to negative 3/4. So my answer should have been 1/2 comma negative 3/4. What should we do after we get our answer, Natalie? Always check it, okay? And if you plug that guy back in, it works for both equations. Questions? Comments? Concerns? What's your concern?
How did you know?
Yeah, go ahead, Mia.
How did you know to put 4 over 4?
How did I know to put 4? Oh, because, right? How do you add fractions? What do you, a common denominator, right? So this one is technically 1/1, correct? But we want to change it so it's something that has a denominator of 4. So you multiply the top and the bottom by 4, so it becomes 4/4. Good question. Any other questions? Andrea?
How did you get 1x plus x in the first part?
Okay, so McCarvin took the 2 and he distributed it to the 1/2 x, right? Remember, 2 is 2/1 times 1/2x. That's going to give me 2 over 2 times x. Do you agree? And 2 over 2x is just 1x. Got it? Okay, good questions, guys. Any other questions? Alec, you have a question?
What was the answer for letter D?
For letter D, the answer was -1, 1.
Okay.
All right, guys, we have one last example, and it's where nothing is already solved for, okay? So when nothing is solved for, pay close attention. You look for coefficients, that's the number in front of the variable, that are 1 or -1, because then they become easy to solve. And prioritize coefficients of 1. So I notice my y's coefficient in both of these equations is 1. Do you guys agree? So we're going to solve for y in whichever equation you want. Let's pick the first one. So it's -x plus y equals 3. How could I solve that equation for y? Austin? Add x to both sides. Now we have y equals x plus 3. Now we can substitute because we just solved for y. So y is our substitution. X plus 3 is what we're substituting in. So we're going to write 3x, the second equation, plus x plus 3 equals -1. We're making that substitution. Now we just combine like terms. We're going to get 4x plus 3 equals -1. Subtract 3 from each side. You get 4x equals -4. Divide by 4. Divide by 4. X equals -1. You plug that back in. You're going to get y equals 2. And your point is -1, 2. All right, turn in these notes.